One. Yeah, all right, away we go. Okay, good people. So this is where we're looking at this Monday morning, afternoon, that is. The first thing by request, this is from some questions from homework last day. So I think some of you missed class, couple might need some updating. So I'll do 1, 2, 3, probably all 4 on the screen. You can help out and get me going on this. Okay, we can get this together. As a reminder, before we get started, one thing you always want to do with these type of questions is take a look at and pull out, if you can, the greatest common factor first. That's like the first step. Okay, I know I mentioned it a couple of times, but haven't done too much with it. So it might have caught you off guard with some homework questions. You're doing it like I told you in class, check the answers, and then they're off. Okay, so we're going to do a couple of these ones again, just to make sure that that's solid. Number 3, someone asked about a test. And if you were to look out at the outline that I gave, yeah, there's supposed to be one today. You know, I scaled it in at the start of the year, but as we've been going along, couple we're behind a couple of days, or insert a couple of days if you like, not really behind. So we'll have the test later on in the week. I think we talked about it. I think we talked about it on Friday. What did we say? Wednesday? Wednesday? Okay, I'm going to say Monday's going to be too late, I think. So I'm going to say Wednesday, Thursday this week.
Yeah, Thursday. Thursday.
Friday's getting, I'd like to get it marked and back to you. What do you think? Zoom says Thursday. Yeah? Schedule wise? See, I care. I think about these things. Peter, schedule wise, Thursday's going to work? Okay, then I'll write it down. That way it's official and it's up to me now to remember. Which, yeah, I'll even put here a second time. Thursday test. Okay, and I'll give you more information about it, all the topics and everything that are on it. Okay, no surprises, by the way. You know, some teachers give easy stuff and homework during the lessons, and then the tests are super hard. For me, it's kind of the other way around. I give you some harder stuff, and then during the test, just pretty regular, just checking off to make sure everything's good. Okay, so Thursday is the day for that. And then today we'll be looking at when we have cubic things added together or cubic things subtracted from one another. How to factor these situations. Okay, that's getting pretty good level. And we'll leave it there and then move on to a new topic. Or no, we got one more topic in this section. Then we move on to a new unit. All right. Any questions? 1, 2, 3. Okay. So I got day 19 on this other screen. I'm going to bring it up. And by request, we'll take a look at number 13 was the first number there. 13, 14, 21, 22. Oh, beautiful. 13. There it is. All right. Okay. Oh, don't want to do that. Excuse me. We'll just highlight 13 down there. That'll be good for us. Okay, so the goal is to factor this thing here. 400 minus 36 v squared. Okay, so first thing to watch is that, or the first thing to try and do is, as I said in the beginning, let's take a GCF out if possible. And this is where it gets a bit tricky for me, because this is a good idea to do all the time, but sometimes there might be a situation where it isn't. So you might have to do some trial and error for this one. It's not a solid step, just a very good idea. Okay, so looking at these then, we've done this process before. How to find the GCF of 436 v squared there. What divides into both? Two for sure. And that will create what next? We divide by this when we get it in here. Yeah, because we got 400 divided by 2, 200. Okay, I heard 13, I heard 18. 36 divided by 2. It's going to be 18. Take your time to get that. Okay, and then the v squared will just stick around like that. Sometimes it's easier to think of multiply. 18 times 2. Okay, that's the trick. So you see 2 goes into both. Oh, 2 times what? Gets me 36. 18. It's easy on the heart. Okay, what next then? What other number divides into both? 2 again, yeah. Yeah, nice. So -9 like that. That works there. Okay, anything else? 2 goes there, not there. 5 goes there. That's the trick. Remember, for 5, it ends in a 0 or a 5. So I think that's it. Yeah. So it means the GCF now is going to be 4. And a little messy on the screen, but I think we can work with it. Right? Our 400 minus 36v squared now, that's going to equal 4, and then this stuff. Okay, that's how we worked it out. We had how we factored. We had 4, and then the part that is left on the inside like that. True? True. I don't think I'm telling you any lies there. You see? The 4 from those, we used to circle it and then bring it down. And then these were left inside the brackets. I used to have it just all up and down, but for this page, I have to do it side by side there. Okay, so these are just in there now. Now, for this topic and for this question, what we have to do is take another look here. Go, what's going on inside of these brackets still? Okay, so what do we got? 100 is a squared thing. 9 is a squared thing. And v squared is definitely a square thing, right? Okay, so that means it follows that square pattern. A plus b, a minus b, right? Does that sound familiar from last day? I'm kind of squeezing it in up here, but we had a squared minus b squared is equal to this thing. That's what we have inside the brackets now. Okay, so 100 is there. 100 is a squared thing. Yeah, so 100 comes from what? That is, what's the square root of 100? That would be multiplying it back in and going backwards. We don't want to do that, actually. Okay. What we don't want to do is look at this inside and see how it fits this pattern. We have something squared minus something squared. Check this out. We have something squared minus something squared, right? Yeah. So we get a couple sets of brackets showing up. That's what we're going to have. Not bad. There's going to be a plus. It won't be 100 though. Watch this. When we go first thing times the first thing, we get that, right? So what times what gives you 100? 15? No. Oh, 50, 50. Not bad. That's true. But what happens is these need to be the same number. Yeah. So yeah, actually true. 2 times 50 gives you 100, but no, we need them to be the same. Or in other words, what's the square root of 100? Yeah, from class we got 10 here. Okay, so the square root of 100, that will be 10 and 10 there. Because watch now, what's 10 times 10? 100. See? So off to the side, you can make a list and try and figure out what those values are. Next then, we got the 9. What's the square root of 9? No, we have a minus 3. Yeah, throwing the signs in there, that's good. So we got, it shows you put a plus and a minus. So we can put a plus and a minus. Someone said minus 3, so we'll put a 3 in there, which is true, which means, no, it's going to be plus 3 again. Exactly. Right? And what, when we had that, or what number do we have? 9. So 3 times 3 gives you that. That's true. And then we need the same again. So that means this v squared gets split up. So we get a v on one part and then a v in the other part. And then that, I'm pretty sure, Yo-Yo, maybe you can help me. This, I think, matches what the answer is at the back, right? Yeah. Okay. All right. So Zoom, any questions about that one?
No, yeah.
No. Okay. We can summarize the steps. Some people like that, right? So for number 13, what did we do? We did the GCF. And then 2, we did the difference of squares, which is a squared minus b squared is equal to a minus b, a plus b. So our GCF was 4. We were left with 109. So that's 10 minus 3v, and then 10 plus 3v. Final answer, 4, 10 minus 3, 10 plus 3. Okay, let's now then check out what was the next question? Number 14 by request. Who was asking about number 14? You. Okay, let's check it out. Off to the screen here. I think it's over on the right. What are we looking at? Woo. Okay, 14's a triple one, eh? Okay, not bad. I'm going to check 21 and 22 before I do this. What do we have for 21? See? I'm going to stick with 21 first because it's difference of squares. The 14 like goes back in time. Okay, so this question here is like what we just did. Number 21. Who asked for this one? You as well? Oh, yeah. 22. That's right. Okay, so first thing, GCF, what's it going to be? Oh, let me write it down first. 81 v to the fourth minus 900 v squared. Yeah, equals nothing yet. Number one, GCF. 9? 9 goes into both for sure. 3 and 3.
I mean, like at first, 3, then 9, and then it's
I'm hearing numbers that are good. Yeah, so what we can do, we went to prime numbers all the time, right? We can still do that. But also if you see bigger numbers that work, that's useful for this. Okay, we don't need to see all the prime numbers all the time. So what I see here is that, yeah, 9 goes into 81, means dividing, right? Because 9 times 9 is 81. We can do that. And we got 900 as well. So 9 definitely goes into 900 there, right? So I'm just going to say the GCF is 9 like that. That's for the numbers, right? And then we got the letters as well. We got v squared and v to the 4, right? So letters, what can come out?
For 900, we can make we can two times 45 is going to be
2 times 450 would be?
45.
45 would be 90.
Oh, yeah.
Yeah. So tell you what, we'll do this the regular way and make sure we get the right and complete GCF coming out. Okay, so we got 81v to the 4 like that, minus 900 v to the 2. Yes, a 3 can come out if you see it there, or a 9 in total. That would be a 27. This would give us 300 there. 3 again. That leaves the 9, and that leaves 100. And then, as we've usually done, we check the numbers. Anything else? No, it's done. Okay, but we can look at the letters now. Okay, so V is there for both of them, right? So we can pull out a V, divide out a V. We get 9V cubed minus 100V like that. And do it one more time since V is also, or V is still in both. So we get 9V squared minus 100 like that. And that would finish that step there. There's nothing else that's common between these two parts. Okay, and so, yeah, I'll just move it up. How's that? Okay, then as usual, we'll put these in their regular spots. That means this whole thing will equal 9V squared for the GCF And it will equal the right part, the part on the right side there, 9v squared minus 100. Looks like that. Yeah, someone in class is going, oh yeah, see? What we have is the same as before, right? We have two squared things minus one another. Okay, the order is different, but the same as before. So it means we're going to have this pattern again, right? A squared minus b squared gives a minus b, a plus b. Okay, so the 9v squared, that just comes down. But now this bracket turns into 2, just like this thing turns into 2 separate factors there. Nice. In class, we got 3 times and 3 times. So I'm going to put a 3 there. And then she also said in the other bracket, 3 there as well. Class got it. 3v. Because there's a v in one, a v in the other. Not bad. Hey, minus 10 and plus 10. Why not 2 and 50?
Because it's not the square root. It's
That-
like just the multiplication of the numbers, but you need the square root.
Nice. Yeah. You need the same number there. You need the square root. Okay. So the square root will give the same number each time, not just any 2 factors multiplying. So the square root of 100, 10. Yeah. Good work. There it is. Yeah. Gets one of those for all that hard work. Okay, so that was 21. Any questions about that one?
Twenty-two.
22 was one of the other ones. Yeah, I'll check it out. Oh, check it out while I'm down here. $22. That's one of those 3 ones. Okay, so I'm going to go back to number 14. So I'm going to assume that the smaller one's easier. And then we'll do this beast of a question here. Whew, with all that stuff. Okay, so number 14 first. Try and beat me if you know this stuff already. So the goal is to factor these things, right? So we got 100x squared plus 180x plus 81 like that. So we gotta factor this thing. Yeah.
So like, here's the square equation.
Yeah.
Okay, it look like that. And so it's literally you can just make one bracket, and you take the first number, like as an 8, for example,
Mm-hmm.
which is like x squared. Here's 100, and you take the last number, like 81.
Yep.
And then you find the square roots of them. So for first one, it's going to be 10x.
Mm-hmm.
And for second one, it's going to be 9. So you just put in brackets. And because there are like pluses, like everywhere there's no minus,
Mm-hmm.
there will be plus in the bracket. And you just put it in the brackets, like one bracket.
Yep.
You put 10x plus 9.
Nice. Perfect. From class, we got the entire solution. Okay, so what we'll do, I'll put that here on the page for you. So one thing to recognize is that there's a fact that we can pay attention to with this type of question. And that is here, what is the square root of 100? The very first thing. Okay, so that's going to be 10. What's the square root of 81? 9, not bad. What do we get when we multiply these two together? Good. 9 times 10. It's 90. Now watch. How does 180 compare to 90? Nice. So notice 2 times 90, 180. Wow. Okay, so this is a special relationship. There's like a secret shortcut for this now. Okay. Shortcut with you. And how it was described was like this. The secret shortcut, when you have this, that square root times that square root, multiplying it by 2 makes a match. You get this. This is what it factors to. Oh, one other piece. I'll say it's going to be like this or like that. Now we have to figure out which one. Okay. So what we do, because it's because we got pluses everywhere, as was said in class, and importantly right there, that means we're going to choose this one. So just like before, we had 100. We take the square root. So that's going to give us 10 for A there. The X is there as well, so we have to include that. When we look at the last number, it's square root of 81, as we just saw, was a 9. But importantly, a plus there, but also there. We're going to have a plus here on the inside. Final answer, squared like that. Squared is part of the shortcut there. Okay, so nice, useful trick for this one. Yeah. Otherwise, what's going to happen? First time's the last. Struggles to try and figure out what the minimum or what the middle number is there. Right? It's going to take a while. Okay, so that was 14. Let's check out 22, I think was another one. Yeah, so this is probably, we'll see what we got here, a mix maybe. Yeah, let's check it out. So I'm going to think GCF first, just because those numbers are pretty big. And then we'll see what we're left with after that there. So we got 200 m to the 4, just copying on the question here for everyone. Looks like that there. M4 plus 80m squared. Oh, that'd be a lie. That one's a 3. And then we got 8m squared there at the end. So this is what we got to factor. Pretty big, right? Okay, let's do the GCF first. Hopefully that can help our lives a little bit. So what do we got? What can go into all those?
I think 8.
Yeah, 8 will go.
8 and 1.
We could do it. It will be 8m too. I'll just do it quickly here with the primes to show you, just because 200 is pretty big. So 2 goes in there, we get 100, right? Okay, that's good. What do we get for the 80?
10.
It's by 2.
Oh,
Slow motion. 40, right? Okay. That's there. 8 with 2. 4. Nice. One more time.
15
Yep.
and 4
M4.
plus 20
Yeah.
and 3
Yeah.
plus 2
Yeah.
and
Nice. So class is getting it there. One more, I guess, eh?
and 2
I'll take the 2. 25.
plus
10.
10 plus 1.
Yeah. Plus 1. Invisible 1. Not bad. And then,
M
yeah, M or M2. What would M2? Okay. Class is saying M2. So we'll divide by M2 and see what happens. The smallest one there, right? So
5 plus
25 times what M is going to be left over? M squared, M to the power of 2. We can do it off to the side. M4 divided by M2. What do we get? M to the 2. Yeah. This one here.
5.
5s are done. The numbers are done. Enthusiastic, I know. Divide by, M squared there. Just M on its own. So this term will be now plus 10M. And then lastly, plus 1. Okay, not bad. Numbers are way nicer than at the beginning. So we get, yes, that's right. Getting ready. Well, this one's getting pretty up there, you know, little by little. But this is what we got now here, 25 M squared like this, plus 10M plus 1 like that. So we do have 2 ways to do this one. We could do the shortcut that we just talked about, or we could just do the regular way that we've done a few days ago, multiplying and then with grouping. Sure, from class.
Why we choose M to like here?
We're here?
Yeah.
Yeah? Because watch, is there an M here? Yep.
Yeah.
There? Yep. There? Yep. How many M's are here? 2, right?
3.
That's a 2.
Yeah, I mean like the last one is M2.
M2. So there's actually 2 M's there, M times M, right? There's 3 there,
Yeah.
4 there.
So
So how many can we pull out? How many are, or rather, how many are in all of these terms? At least 2. So we can pull 2 out at a time.
so it's like for example it's M5.
M5.
Choose M3.
No, because this has only 2 M's in there.
Like at the end like
Oh, good. If class is asking if this was at the end, if this was M5 here, right? And everything else the same, then yeah, you can pull out an M3. M to the 3, because there's 3 there, 4 there, 5 there. How many can you pull out from all of them? 3, right? Can you pull 4? Not from this one. That stays as a 3, right? It's not enough. So 3 is the most in all of them. So you'd pull out a 3 then. That's how that works. Okay, not bad. Good question. So then to factor this thing out, yeah, 2 ways. Shortcut we just did, or do it the regular way. And you get an answer, it looks like 5M plus 1. And you will find that you get the same bracket showing up. It'll end up being the same thing. And so the cool, good looking final answer would be 5m plus 1 all squared like that. Okay, if you had this, yeah, that's okay for now. We'll tighten it up by the end of the semester, but this is a good looking one. All right, good people. So good work so far. If we're done with all those, we'll get on to we'll go to the PowerPoint then and take a look at what we got to look at today. Get that out of there. Got that like that. That looks good. Perfect. So let's see what we got. Had some warm-ups, but our warm-up was definitely bigger with our 1, 2, 3, 4 questions that we did. So no need to do these. You can try these at home if you like, or perhaps we'll get to them later in the class, but we're good in the warm-up situation. This is what I want to show you today. It's a different situation that comes up. Instead of having squares of numbers with 9s and 25s and 81s, we got cubes of numbers that are being added or subtracted from one another. So maybe just as a warm-up here, what are the cubic numbers from before? What's the cube of 1? Yeah. What's the cube of 2? 8 it is. Next, cube of 3. 27, yeah. 4. Nice. I'll take a 64 for that one. Thank you there. 5 cubed. Nice, 125. It's getting quick too. 6. What's this one? Oh, I put it squared. Look at that. Let's make it cubed. 216, I think there. Yeah. We got 180 plus another one. So I think when I introduced this topic a long time ago, this was one of the struggling ones, right? It's true. Cubed there, 216. 7 cubed. 343. Yeah. Yeah. I think of it as 350 less a 7. Yeah, that's good. Yeah. Yeah, that's good. One more. Just because I think I know it. 8 cubed. That's 3. That's nice. How'd you get so fast? Yeah. Yep. The trick with here is 8 is using exponent rules. 8. Yeah, 1024. Yeah, perfect. This was the trick there. And then this ends up being 10 to the 9, which is close to 10 to the 10, which is 1024. Divide that by 2. A lot of words, right? But can be done pretty quick. So we got to keep these in mind because look what's going to happen. We're going to have a question like we have here. 8 plus 27 b to the cubed, right? b to the cubed. b to the 3 or b cubed. And so notice 8 is one of our cube numbers, right? 27 is one of our cube numbers there. So here's what we do. First thing we're going to do is find the cubed roots from our from the expression that's there. So I'll put our expression down that we're looking at. A plus 27 b cubed, right? So what cube roots do we need? Well, first one is the cubed root of 8. Okay, so that's just going to be 2, since 2 cubed is equal to 8, as we just talked about. So that takes care of the first term there. Same for the 27. Cubed root of 27, what's that going to be? I'm going to take a 3 there. And that's since 3 to the 3 is equal to 27, right? Okay. And then lastly, this is more for a teaching situation, but the cubed root of 3, what is that going to be? Well, remember that when these are the same, they're opposites of one another. So just b. Since cubed and those are opposites. So they kind of cancel one another out. Actually, no kind of, they do. So these now are the pieces that we use in the formula there that we are given for free, the one that you see up on the screen there. Okay, now, there's one important piece to notice, and that is we have a plus on the inside. Okay, so we gotta pay attention to that as well. But I'll comment a little bit more about that on the end. Let's just put all these values in. So that we can work this thing out. Okay, so the cubed root of 8, oops. There we go. The cubed root of 8 goes first, so that's going to be the 2 that goes there. This 2 that we get. Next, because we have a plus here, that's going to be the plus that we have. Okay. For the next part, we're going to have 3b showing up in there. Where from here? 3 and b. Okay. Yeah, what I'm going to do is for this part, I'm just going to substitute it in, and then we'll actually work it out in the next step. So for here, we got the 2, that's going to be squared.
Actually, why is there a minus?
Why is there a minus here?
Yeah.
Well, someone else asked me that earlier in class, or even before class. The short answer is because it works, which isn't very helpful. But what I could show you is we can get this answer from doing division. And so the division kind of forces it. It means it has to be minus for it to work. But it's sort of a mathematical way to show you, as opposed to a teacher just telling you. All right. So it's minus in there. It's minus the first thing times the last thing. So 2, and then times 3b. Then we have the last part there, plus 3 times b all squared like that. And then what we would have to do is simplify this as much as possible. Expand out the exponents, multiply those, expand the exponents. So I'll just say simplify. All right, so what we'll do is show the whole, what do we do so far? First of all, we took a look at the first term, found the cubed root, and then we used it within the formula that we were given there. We looked at the second part, found the cubed root of that, 3 in the b. And then we used that in the other part. Okay, and then we got to simplify. So what I'll do is I'll show this question from the start all the way through to the end, so you can see how it can look. All right. So here we go. This would be the official style. Not fine, but factor 8 plus 27b cubed. Okay, so number one, what we look at is since we have a plus on the inside, what we're going to do is we're going to use this formula here. A cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared, like that. And then the next part, what we're doing is we're finding a and b so that we can put them into this formula on the right side here. Okay, so how do we get the a? Well, that's the first term. Just check this out. We're going to take a look at one part of this. So the a is going to be the cubed root of 8. Because a comes first, right? A is the first thing. So what's the cubed root of 8? We saw earlier. And it's equal to 2, right? Okay, so that means a is going to equal 2. That means everywhere there's an a, we're going to put a value of 2. The second part, that comes from here. B is equal to now the cubed root of 27b cubed. Cubed, that's a 3 there. So now we go back in time to, I think, one of our first sections. This would be same as this. Cubed root of 27, cubed root of b to the power of 3. I'm getting a little messy on my screen here, but what I'll tell you for free is we get b is equal to 3b now. So wherever there's a b showing up, we put 3b on the inside. Okay, so now what we got? Well, what we're going to have is a plus b. So I'll circle that here. That's what we have for a, and that's what we got for b. So we have 2 plus 3b there. That goes there, that goes there. These other pieces are filled in. So we got that a is 2, it's squared, minus 2 times 3b. Just substituting those in. And then lastly, b is equal to 3b squared. Put it in brackets like that. And then this is the algebra that you do. Go to exponents. What's 2 to the power of 2 equal to? 4. 2 times 2. How about this? 2 times 3. What does that give? Way easier. 2 times 3.
6.
Yeah, this here is just 2 times 3. They're written side by side. 3, yeah. 3. That is a B. It would be 72 otherwise. Yeah, you're right. But no. I'm going to use X. I'm going to use X next time. So minus 6 there. And you're okay with that being a B? Yeah. Made me nervous for a second. No, I'm not so nervous. This one, though. Okay, we got exponent rules. What's this going to be? Going back in time. It's going to be, you know what? I got a bit of real estate. I'm going to do it in one more step. This b squared goes like this. When you have a squared upstairs, the rule is it goes to each thing on the inside like that. That goes back to exponent rules. Okay. So the front part, that stays the same. 4 minus 6b, that's all there. We just got to update this little part. Oh, not an equals yet, a plus. What is 3 to the power of 2?
9.
9, that's right. This means there are 2 3's multiplied together. This means 3 times 3. Yeah, so that'll be 9 when we get that. Can we see this? If we add, can't, 2 times 3, 6. Oh, I want to do 3 times 2, 6. 3 to the power 2, 9. Right there. 3 times 2 is 6. 3 to the power 2. See, 2's in a different spot. Means something different. 9 like that. B squared there as well. Close the bracket off there. It should be there and should be there. And that finishes it off. Okay, final answer there. We've factored this thing so that it's now 1 factor times another one. Yeah, difficult, right? Difficult first day. Okay. We'll do another example though. Notice we got difference. We got a minus in the middle. So that means we use a different formula. Okay, we got a minus to start with. If you look back, when we have a plus, we got a plus to start with. Here we have a minus. We got a minus in the to start with. Okay, and the second part is different as well. Okay, when it's a plus, it's a minus over here. Oh, and when it's a minus, it's a plus over there. It all fits together. Yeah, yeah. So we'll work through this one in the same sort of style, so you get some practice with that. And then if there's time, I'll try and answer that question of like, why is it like this? And we'll take a look at some other questions. It's because it's cool to ask that. Okay, so here we go. This is our challenge, good people. We have to factor this thing. 64 a cubed minus 27. That's nice. We've seen that one before. Be 3 like that, okay? You know what? You can put it on the board if you want. And we can check. How's that? So how do we do this? Well, first thing is that's since it's a minus, since it's subtraction, right there, that means we're going to use this version here. We're going to have a cubed minus b cubed is the same as a minus b, a squared plus ab, and then plus b squared like that. All right. Then we got to find what a is and then find what b is. I'll do it in 2 separate steps. I put it all together previously. So a is equal to what? Well, I can do the, since we got 64 right? If we take the cube root of both sides, cubed root, going back in time, a is equal to, well, what's the cube root of 64? It is, yeah. The right-hand side is going to be 4a, okay? And so that's what we're going to use in our formula here. So the next we got to figure out what the b is going to be. B is equal to what? Okay, so what I know is b cubed is equal to 27b cubed. So take the cubed root. Cubed root. These undo one another. They're opposites, right? So we get b there. What's the cubed root of 27? What? Yeah, what times what gives you 27?
3.
Nice. 3 it is. And then we got b to the 3 being cube rooted. They're opposites. So we're just left with b only. All right. Okay, so I think this page is looking pretty good. He's got a question here. Because we have a cubed thing, one of our cube numbers, that's a 64. Because we got a cubed thing, that's a 27. Yeah, definitely we got difference of cubes happening there, or subtraction of cubes. Okay, so that means we have this formula to work out. That means for this one section, we work out what A is going to be. We got it, 4A. And for the next part, we got to figure out what B is. So we do that. So everywhere there's a B, we're going to have 3B going in there. So I'll leave that up, hopefully. Yeah, perfect. So I'm going to substitute it into the formula that we now have there. Okay, so we're going to have that's like this. The question is 64A cubed minus 27B cubed. The A we got still on the screen. Yeah. The A is 4A. So that means we got 4A minus 3B. That takes care of the first brackets there. And then for the next one, do the same. A is going to be 4A squared plus 4A times 3B. And then plus 3B squared like that. Just using the formula. Squared is there, so squared is there. Squared is there, so squared is there. And now we got to simplify what we have, what we've created over here. So what do we get? Our exponent rules working out now, right? What's 4A squared all going to be? 16A squared is. Okay, the next, what's that going to be? 3B, not 36. It's way easier. That's right. The numbers only. 4 times 3 is 12. And then A with the, yeah, A6, AB over there. Perfect. The last one. We've seen it before, but also going back to exponent rules. That will be 9B squared when you work that out. And good people, that finishes that off. Okay. Yeah. Yeah. Bit of a workout, eh? So let's see. What we got for the homework questions here. Yeah. So for class, what I'll do is I'll put them up on the screen, and I think the worksheet goes from like, I don't know, 1 to 90 or something like that. So that would be insane. We're going to be here until January if we do them all. So it does say odd numbers, but that still means, yeah, quite a few. Okay, so we'll take a look. It's going to be the homework. Yeah. Okay, so then what we got, I'll hand this out to people in class. Zoom, I think you have it in Teams already, so you can access it there. And what we'll do is the first couple of questions together, right? Just so we can start feeling good about this stuff, or maybe even some of the harder ones together. That would be smarter. Then leave the easier ones for you to do. Okay, so I'm gonna stop recording for a second, hand out the sheet we got to the class. All right, good people, this is our challenge. We got to find the factor of this thing. And we got to make the answer look good too. If there's too much talking, too much writing, it gets pretty long, right? So let's try and keep it organized. 343 m to the power of 3 plus 64 and n, different there, to the power of 3, like that. Okay, so good people. First thing to do is what? If you think back to those earlier examples. It's all factorized.
How do you find the square roots? So it's 7 and 4.
Not bad. The square roots wouldn't work because we're talking about cubed roots this time, officially. Just for the language, yeah, cubed roots. But actually, that's actually the second step. What's the first one? I'm going to write the word since, and that might trigger. Since.
And then A equals 342. I mean,
Mm,
you have to write the whole formula.
yeah, so it sounds bad. You got to write the whole formula. But importantly, you got to write the correct one. There's a plus version, and then there's a minus version. They're different from one another. Okay, so I'm going to say since we have a plus, yeah, now you do write the whole formula out there. Since it's the plus version. And you might have to go back to your notes by all means. And I think even on a test or something, I'll probably give you the formula. But you'll see that there's a little pattern there. Sign is the same for the first set of brackets. And then this sign here at this location is the opposite. No need to memorize it actively. I think you'll absorb it over a couple of days of doing this type of question. Okay, so that's good. Long, but it's good. And yes, now number 2, now we do find what A is going to be. We do find the value for A and the value for B. So I'm not going to write since again. I'm going to write 4. For A, what do we get? A3 is equal to 343 m to the 3. So doing the cubed root, and I'll just show it like this. Doing the cubed root, we get the cubed root of 343 m cubed, which gives a final answer, yes, as I heard in class, of 7 times m, like that. Same style for B now. For B. B to the 3 is 64 and to the power of 3. So taking the cubed root of both sides, we'll get B is the cubed root now of n to the 64 n to the 3, which I think is on the board, is it not? Or is that a different question? Different question. What do we got for this one? What's the cubed root of 64? Yep, cubed root of n cubed, n. Okay, so these are now the values that are going to go in for A and B. in our formula that we have up there. Okay, so I'm going to try and keep these on. I'm going to rewrite the formula. You don't have to if your work's all organized. So I'm going to have it like 343 m cubed. Oh, plus 64 n cubed. That's going to equal 7m plus 4n. And substituting in, we got 7m squared minus 7m. Save that. 4n. Watch the signs there. And then 4n squared there at the end. 4, not 14 over there. And we get our final answer just by doing a little bit of algebra that's there. So we get 7m plus 4n. And exponent rules now. The first term becomes what? Not 14, as I almost said. What's it going to be? Yeah, 49 there. 49m squared. That's for that. The next term. True. Yeah, it'll be minus 28 for sure. Mn, nice. And the last one? 16n squared. And that, good people, finishes that question off. Okay, should we do another one? It's a bit of time. Or any questions from this one?
Let's do the 23rd one.
Last, yeah,
Yeah, just because
I know. From class, you got to respect intelligence. The guy in class said, let's do the hardest one. I said, yeah, okay. It's a good one. Maybe I'll give you hints here, then you have to do it anyways. How about that? No. What is the last one? 23, you said? Whoa, look at that. What's 24? A baby question.
Yeah, 24 is like nothing.
Kid question at the end. Okay, 129. I have no idea. What's 129? It wasn't on my list. I didn't go that high. I'm going to stall and write slowly so I can figure it out ahead of you guys. Factor 29. Huh? You have the other one, right? You can try it if you like. Yeah, you can go. The other guys, we can stick around. Parsa did it the other day. See you tomorrow. Thanks. Y x cubed 24 y to the 4th. Okay, so listen, any ideas? Can't stall any longer. In my brain, I got these on the screen, the cube numbers. 24 isn't one of those, so that's not any good. Might have to do a GCF first for this one. So let's see. Does 3 work for these ones?
like 1 plus 2 plus 3.
3 works. Nice. 3 will go with the trick here, right? 1 plus 2 plus 9 is 12. 12 divides by 3. So yes, that divides by 3. 24 for sure. Okay, let's do it. 3 is the first number. So what do we get? 3 and stuff. And we get 3 there. Yeah, I'm getting 343 when I do that one. That's interesting. That's nice then. Because do you recognize that one, anyone? All right. So dividing, don't distract me. Working hard for you guys. 24 divided by 3, 8. So that follows that, our usual steps. Coming out next, a y, I think you would all agree, don't forget. Otherwise, you'll get to the answer. You'll just have to.
Yeah, but there's going to be like, if you take out, there will be x. Okay,
X is there. And even if, importantly, x cubed, right? So, and then leaves x, y to the 3 like that. Okay, so at least at this step, what we can do is 3y and then write this other stuff down and then hope that it's useful and meaningful. And then we can do something with it. Well, no need to hope, because of course it is. This thing is a squared, who said that? Cubed term. That one is as well. And then they just happen to be added together. Okay, so we now got to get the correct formula as well. Okay, so this is like step 0. Then step 1 is, what is it? Since we have a positive, we're going to get the positive version of the formula. I'm going to put it on a separate page, otherwise chaos, too crowded. Okay, since positive, then we get the formula. And then the next part would be A is equal to what? And then B is equal to what? And then lastly, simplify. But I'll do that all in the next page. So since it is positive, the formula we're going to use is a cubed plus b cubed is equal to a plus b opposite and plus b squared like that. What do we got for a and b? Well, we should have done that first.
A is 7x.
Yeah, a is going to be 7x if you work that out. And similarly, yeah, b will equal 2y. And then now we're good to go. So I'll put it in here. Yeah, a is going to be 7x plus 2y. That means a goes in there. Now brackets around the 7x, so to capture the whole thing. Okay, the square needs to capture the whole 7x. Same with the b here. It needs to capture both the 2 and the y, so it gets a set of brackets. And so that gives us then our final answer. So once we simplify the inside here, I'm just going to write it so you can see the whole thing. 129 yx cubed plus 24y cubed is equal to what? It's equal to 7x plus 2y. And now the exponent rules kicking in. This first term will be 49x squared, since that exponent goes to both things inside the brackets. This will be minus 14xy, as we've enjoyed a couple times in class. And then the last one will be, last term will be 2 squared y squared, which is plus 4y squared. Finishing that question off. Okay, so I think we'll leave it there for the video. Feel free to turn back, check it out, watch it, and pick it up next day there.